Let's take a look at this example. For those of you who have difficulties to look at the problem and realize that these three resistors are in parallel, I would like to just explain that you have to always look at the terminals of your power supply. This is basically how I found if the resistor is in parallel or is in series. Okay, just take a look. We have positive terminal. Positive terminal is connected to resistor R1. Okay, this one is also connected. The positive terminal is also connected to what? To resistor R2. Okay, and positive terminal is also connected to resistor R3. Okay, negative terminal of my power supply is connected to resistor R1. So it means that my R1 is connected directly across voltage source. I mentioned that positive terminal, okay, this is the positive terminal, this is the negative terminal. Positive terminal is connected to the resistor R2, and also negative terminal is connected to resistor R2 at the bottom, right? On this side we can say, okay, so it means that voltage source is connected directly, okay, to the resistor R2. And let's take a look at resistor R3. R3 is connected to the positive, and R3 is also connected to the negative terminal of my V1. So I can redraw the circuit, and my circuit is going to look like this. Okay, so this is my R1, this is my R2, okay, and this is going to be my R3. This is my V1, and this is my ground. Okay, so now we can see very clear that these three resistors are in parallel. So if you want to find the current through each resistor, we're supposed to use Ohm's law. So we can say that I R1 is equal voltage across resistor R1 over resistance R1. Okay, now let me just remind you that V1 is equal to voltage across resistor R1. This is also equal to voltage across resistor R2, and this is also equal to the voltage across resistor R3, because in parallel circuit all resistors are connected directly, okay, across the voltage source. So VR1 is equal 15 volts over R1, which is equal 4.7 kilo ohms. Okay, so this is equal 15 divided by 4.7 exponent 3. This is equal 3.19 milliamps. 3.19 milliamps. Okay, so this is my IR1. IR2, the current which goes through resistor R2, this one is my IR1, this is my IR2. So this is equal to VR2 over R2. VR2 is equal, again, 15 volts. We said that over here, right? This is equal to 15 volts. So we have R2 equals 3.9K, 3.9K. Now I'm going to use the calculator, and we have 15 divided by 3.9 exponent 3. This is equal 3.84 milliamps. 3.84 milliamps. Okay, next I'm supposed to find current which goes through resistor R3. So IR3 is equal VR3 over R3, which is equal 15 volts over 5.2 kilo ohms. This is equal 15 divided by 5.2 exponent 3. This is equal 2.88 milliamps. 2.88 milliamps. Okay, in order to find I total, I'm going to use KCL. KCL says that the total current is equal to the sum of all currents in the circuit. Okay, so we have I total is equal IR1 plus IR2 plus IR3, which is equal 3.19 milliamps plus 3.84 milliamps plus 2.88 milliamps. Okay, so I total is equal 3.19 exponent 3 negative plus 3.84 exponent 3 negative plus 2.88 exponent 3 negative equals 9.91 milliamps. 9.91 milliamps. Someone would say, okay, so how I can verify that my answer is correct? So what I would do, I would simply calculate first the total resistance. Okay, calculate the total resistance, okay, using these values. So because I have 3 resistors, I have to use following formula. R total is equal 1 over, and I have 1 over R1 plus 1 over R2 plus 1 over R3. This is equal 1 divided by, open parenthesis, 1 over R1, which is equal to what? 4.7 K. 1 divided by, and we have R2 equals 3.9 K plus 1 divided by R3, which is equal 5.2 kilohms. So 5.2 kilohms. Okay, so this is equal, R total is equal 1 divided by, open parenthesis, 1 divided by 4.7 exponent 3 plus 1 divided by 3.9 exponent 3 plus 1 divided by 5.2 exponent 3. Close parenthesis, this is equal 1.51 kilohms. 1.51 kilohms. Okay, so this is the total resistance in my circuit. Next, I'm going to find the total current. I total is equal V1 over R total. Okay, please keep in mind that the circuit, okay, this circuit which we get, we can substitute by simply one resistor. Okay, and this is going to be my R total. Okay, so this circuit is going to be equivalent to this one or this one. Okay, it's going to be simply the same thing. So I total is equal V1, which is equal 15 volts, over R total, which is equal 1.51 kilohms. So let's calculate it. We have 15 divided by 1.51 exponent 3. This is equal 9.93 milliamps. 9.93 milliamps. Now we're supposed to compare the currents. We got 9.93 milliamps, and before we get 9.91 milliamps. So these values are very close to each other. So we can say that our answers, okay, our answers are correct. So we can say that the problem is solved.